Next up, we have Elisa and Paulo. Elisa, there we go.
Good morning, everyone. That was a perfect segue into what we're going to talk about now. We're engineers and we're solving problems. This is Paulo, he's with PM Account, and I'm Elisa with Netflix. So we're going to talk about how we put a whole bunch of technologies together mingled it into one thing, and resulted in a working setup for us at Netflix to be able to see where our traffic flows to via NetFlow, which we were not able to do. Back. Clicker. No clicker. Next slide. No clicker here. Oh, perfect. Thank you. Okay, so this is what's going to happen. PM Account is our favorite NetFlow accounting software or flow accounting software, and it's great because it's flexible in a way that you can adjust it to your problems. When we faced an issue on how to match our data at Netflix, any other out-of-the-box tool was not capable of doing anything about it, and we could go along and take PM Account and customize it in a way that it would solve our problem. So we're going to walk you through the steps of starting with how the Netflix network looks like and how we deliver our traffic. And then Paulo is going to introduce you to PM Account and solve the big mystery on whether it's called PM Account or PMACCT, because no one really knows. And then the abstract might have given it away already that we used a BGP edition called AddPath, mingled that into the picture to be able to map our data the way we want to map it. We'll explain a little bit what AddPath does, and then at the very end we'll conclude in putting all of those pieces together and explain how it all works for us. So let's get started with Netflix. Who is a Netflix member here in this room? Quick show of hands. Hey, that's not enough. Okay, so we're nearing the 50 million subscribers now. We deliver movies and TV shows. We're available in about 40 countries right now. Have pops in different parts of the world. I'm gonna go a little bit over some details. This is where Netflix is available as a service. It started out in the US, added Canada, South America, and then in the past couple of years we've been going more and more into European countries. Netherlands just came up last year, and then you might have heard the announcements, Germany and France are gonna be next up this year. So we're working hard on expanding our services all over the place. Open Connect is what we call our in-house CDN solution. Essentially, that's the group at Netflix that takes care of all the caches and servers that hold the movie content, and then of all the routers and network to deliver that content. The network is based on a mix of vendors. We have Cisco's, we have Juniper's. We recently started adding Arista switches to the mix on the side of our core routers to essentially increase port density. We have the caches are connected to our core routers, and we deliver the traffic of those caches right to transit, peering, and anything that is connected there. We do not have a backbone. So those are separate islands we call it a network, and I think you might be able to call it a network, but those are separate islands of what you see on this picture, router, caches, connected transit, and that's pretty much it. We have a system of putting caches into other people's networks. So, a cache that you place to serve your subscribers out of your own network. If you want to talk to us about that, go to netflix.com/openconnect. That's how that explains how that works. So no backbone is how it looks like. We do have POPs in Europe and South America. This is a view of the US. Separate islands of routers and caches, not connected to each other, don't talk to each other directly. The magic, though, that decides how or where the traffic is delivered from happens in the cloud. So those routers, those islands, send the routes into the cloud, and then the cloud does something similar to a BGP path selection process, but not quite. It takes into account some form of policies and geolocations and a bunch of other rules that are added on top of that. And then that cloud decides where the end user would get their traffic from. So it makes the decision where it is sourced versus then the router in your island that the cache that you've been directed to makes the decision on how it egresses the network. It looks a little bit like this. So the end user, the client, has his TV, connects via different browsers, PlayStations, whatever client you have at home and what you use. When you send your request to Netflix, it ends up in that cloud that is aware of all the routes we have all over the network, and then it will tell you which island do I contact to actually get my movie from. You go to that island, and then that island will serve you with the content. And in case you guys didn't know, Orange is the New Black comes out on Friday. All right, and then that island, once you request your traffic from that island, it will distribute it over either peerings at internet exchanges, or transits that we have on that particular router. In many cases, the amount of traffic we have is actually too much to serve via a particular provider. So we have mechanisms in place to split those up. We use a form of weighted multipath that would send 1/3 via one transit and 2/3 via a different transit. And that's where our problem with NetFlow comes into the picture. So everyone does flow accounting to know about where the traffic goes to do their peering analysis. In our case, also to figure out how certain paths perform or not perform, because we're delivering the traffic in a way that we're looking to have for our end users to have the best user experience they can get. That's why you split it up and weigh it over different paths. So taking any out-of-the-box NetFlow accounting software, it does not know how to handle multipath if we send a portion of the traffic towards not the first best BGP path we receive on that router. So this is the problem we were facing, and we'll get into how we solved that later on. And first, Paolo with some PM account or PMACCT.
Yeah, I call it PMACCT, but I value differences, so feel free to call it whatever you want. So yes, so what is? Yes, okay, perfect. So what is PMACCT about? It's that thing that is sitting over there in the middle. Essentially, you can get network traffic data via telemetry, so NetFlow, IPFix, SFlow, or packet capture, so lib pickup over there. You can correlate or augment this network traffic data with other sources of data, for example, BGP, IGP, or user-defined maps. User-defined maps could be whatever of interest, anything that is, I don't know, for example, matching an IP address to a radius username, an interface to an AES number, so that you give better chances to the source peer AES, and things like that. So whatever makes sense to tag network traffic data with, that could be a user map. And then you take this traffic data, possibly augmented by other sources of data, and then you store it persistently on a wide variety of natively supported backends. So you see over there, there is a selection of open source relational databases like MySQL, PostgreSQLite, NoSQL databases, flat files, and also RabbitMQ, which was the choice as a AMPQ protocol implementation, so a message exchange to ship traffic data to third parties encoded as JSON objects. This is PMACCT as a NetFlow IPFix collector, but PMACCT could be also something out of scope for this presentation, but a replicator, proxy, or a probe for this. And best of all, it is a free open source software, so you can really go to the URL on the bottom of the page and check it out and getting started. And as soon as you have problems, then you can just stop me by. So a few non-technical facts about the project. So it's, I would say, quite an established project by now. So it's more than 10 years that I'm running it with much passion, I would say. LinkedIn is ticking the clock. So it was saying the other day, it's 11 years and 3 months or something like that. It comes with an awful name. I'm a very terrible marketer about it. And yeah, unfortunately. So as I was saying, it's free open source and very importantly, independent, let's say. It doesn't pose itself the idea of reinventing the wheel. So it's under development and innovation. It's being introduced and it is essentially what we are discussing here today. There are very strong ties with the service provider community. I come from that community myself, so I'm very happy about that. So I actually code PMSCT, but it's also thanks to many people in this room for if it is what it is today. And it is being deployed also at very large service providers around, like Netflix, for example. Two key features. So let's switch to a little bit more technical things. Let's say two key features, let's say, of the PMSCT software is that, you know, in that chain that you read data from the network and you store it, let's say you have also data reduction techniques. So spatial and temporal data aggregation, tagging, like I was saying before, filtering, support for sampling, so renormalization of counters, rescaling of data, and things like that. And so also the ability, another key feature of collecting traffic once and then providing multiple views of the traffic. So for example, in PMSCT would be very legal configuration that, for example, you can have instantiate two plugins, for example, and one, you keep raw data in flat files with whatever retention time. And you can also aggregate at the very same time in another plugin instance, an aggregation method. You are really exposed to the primitives of the traffic. The traffic also layer 2, layer 3, layer 4, BGP, and things like that. And you can do an aggregation like ingress router, ingress interface, BGP next stop, peer destination AES, which is great for traffic matrix for capacity planning purposes. So the idea is that you have the minimum data set to solve your project so that you can work in a project-oriented fashion and not the other way around, the traditional way 10 years ago, which was essentially, collect terabytes of NetFlow data and then recollect it back to solve your problem. PMSCT and BGP. So first of all, why BGP as the collector, right? So because it's a legal question. Somebody can say, we already have source and destination AES information in NetFlow. Why we cannot just add further information in BGP information in NetFlow? So my take on that is that that would be suboptimal. And you really want to correlate NetFlow and BGP at the collector, so also NetFlow with other sources of data. So telemetry should be reporting about forwarding plane. It should not encapsulate somehow something like BGP, which is very well working. Well, okay, it's a working protocol, let's say. So PMSCT got, back in the years, introduced a BGP daemon in the code. It works as a parallel thread. So imagine that there is a thread that is collecting NetFlow and another thread it's keeping up the BGP peerings. And essentially when there is NetFlow data coming in, essentially PMSCT is looking into whether there is a routing table from that same router. And if there is, then the traffic data can be augmented with the BGP data. I was working for service provider myself for many years, so I was very paranoid about applications speaking to my protocols, to my routers. So that's why I made this implementation as less intrusive as possible. So no updates whatsoever, passive BGP enable. It maintains per BGP RIB, per peer RIB, and that means that makes this implementation a root server. It supports whatever it should support, BGP peer should support in 2014, and caveat that you see at the very end. So BGP multipath is not supported. This is outdated information, and we will see in the next few slides why is that. So let's do a brief digression of BGP add paths before, let's say, putting everything together. So what is BGP add paths? So BGP add paths, it's a draft at IETF. You can check it out if you're interested. And essentially, in very simple terms, it's an extension that provides extra visibility into, let's say, best paths. If you have more than one path, so that goes hand in hand with BGP multipath, and let's say backup paths possibly. So it's the NLRI encoding, it's changed, and you can see that there is at the beginning that path identifier for octets. So that is a virtualization layer, not much different of what happens for a root distinguisher for VPNs. And so BGP at paths, it's not a novel topic, and it was already spoken here at NANOG, and there is a presentation of whether extra flooding of information is good or bad. So add paths, it's a spoken topic in the context of routing, right? So, but we are taking a new angle in this discussion, which is was not spoken before, so that's why we're thinking it's an interesting presentation. So it's, let's say, BGP add paths in the context of monitoring. And BGP add paths has some limitations as well, because it was born for routing, of course. And there is also a draft in which I'm personally involved, and it's over there at ITF, where we are trying to make it a little bit better or more pleasant for a monitoring application. And yes, let's start putting everything together.
Let's start putting everything together. So let's get back to how Netflix receives multiple routes on each router island, and we essentially can forward the traffic to a particular destination via either one of them, depending on how they're weighted in our system. So in this example, we have one destination, we have 4 different paths that we can get there to that destination. The NetFlow traffic that will get to the collector will not know anything about the BGP, so the collector PM account, as Paolo explained, will have a BGP feed coming in and will try to do that matching, but then that BGP feed on the very bottom, you see, will only know the best path that is that PM account gets in. So with add path, it looks a little bit different. With add path, the collector PM account would actually know all 4 paths that are here on the very bottom, and we can make our matching where the traffic actually went to.
Yes, and see, so that's where everything starts getting together. So we have BGP add paths in PMSCCT now. So we were working with Elisa already beginning of this year, end of last year, and the feature went to general availability in April 2014. So why BGP add paths? Because of course, as many of you know, there is also out there BMP, which is BGP monitoring protocol. So PMSCCT is a monitoring application, so we should have a great match over there instead of speaking add paths today. But the reality is that, let's say, BMP comes in 2 flavors, pre-policy and post-policy. And the pre-policy version is the one that is more widespread at the moment, and that puts the monitoring application into the unpleasant exercise of having to parse policies. So if you want to do that because it's part of your exercise, that's good. Otherwise, I mean, it's a big trouble, I would say, doing that in a multi-vendor environment. And so it was not in our interest to use BMP pre-policy. So there is also BMP post-policy, but let's say it's in very early adoption. It's being adopted at the moment only by Juniper, which was pushing for it quite a lot, I would say, at ITF. And let's say, so maybe in 2015, 2016, it will make sense to have also a possibility to do this very same exercise with BMP. But today, 2014, you need visibility into best paths or into backup paths. BGP add path is the way to go. So let's say we have visibility into the N best paths, very good, but what we do now, because of course we have traffic on one side and we have control plane information on the other side, we have got the visibility, and then we should try, let's say, to link these two information together. For sure, there is one thing we don't want to do is we don't want to mimic, let's say, how a router or any let's say, or any model of every vendor, it's hashing flows onto paths, right? We really don't want to do that. So we had an idea. Actually, it's the simplest idea that you can think of, and we said, let's give it a try, right? So which is, let's let NetFlow tell us where things are being hashed, because in NetFlow v9 and IPv6 and IP6, you have a BGP next stop field as well, right? Of course, we were concerned because, especially with ingress NetFlow, right? It's not to be given for granted that that value is accurate, right? It's not intuitive. It's not. It's something that could go very wrong, right? You can be passed just a BGP next stop. So what we did, it was a very incremental, let's say, experimentation. So we tried with one vendor, with one model, with one OS. We were satisfied, and then we moved to the next one, and to the next one, to the other vendor, and things like that. And we were pretty happy. So once in a while, we were lucky, and that's great. So that the simplest solution was actually working. So NetFlow was carrying, the correct BGP next stop. And so that information is then used as a selector among the different paths that we receive from the BGP add paths. And yes, it was my slide, sorry. Sorry. Yes, and so this is just a demonstration. So it's a visual, let's say, representation of what I just said. So we have NetFlow, and you can see it's circled in red that we have the BGP next stop field or next stop field. And then we have the four paths that to PMSCCT via add path, and then you see circled in red that we can match the two information together.
All right. So lastly, this is how everything is set up all together in our network. We have multiple locations that we deployed PM account collectors at. Due to the mix of different vendors we have a different set of, we have NetFlow version 5, we have some IPFix. So we had to make sure with Paolo that everything is consistent and that everything works with PM account as well as in the matching process that we perform. We set up add path on those on our routers towards those collectors on the BGP session with PM account. It is again a mix on Juniper's. The add path comes in different flavors, modus I think it's called, where Juniper implements add 7 and can export a maximum of 7 paths to a destination, where versus Cisco that exports at all, anything single path you would get. We typically don't have more than a handful of paths towards a single destination, so we verified that it actually covers everything we have, and this is what we ended up with. Thank you. Any questions?
So I'm LJ Walker. I work for Cisco. I'm actually kind of proxying a question from Daniel Walton, who's a good friend of mine, and actually wrote the original ad path draft. He wanted to know when his Netflix free subscription was going to show up. No, seriously, that's all. I literally got a text message saying this is the first real viable use case that he'd seen, and he was just interested in when that was going to happen. Thank you.
Thank you.
All right, thank you very much.
Thanks.